We're starting to get into some more sophisticated topics with our geometry study, and this is going to help us speed up the analysis and the critique that we can make about the geometric figures that we're studying. And it also helps us to deduce more in-depth things about what we're seeing. And so this is going to really help us build up to the study of quadrilaterals and other polygons later on in the year. So the topic today is parallel lines and transversals. This is a new word, a transversal. It might harken back in your mind to the transitive property. They both start with the prefix trans, which means across. And so I want to talk about what this new word transversal means. So here we have two parallel lines, as you can see. I've beautifully drawn two parallel lines, or at least sketched them that way. And then this line cutting right across them, again with the word trans, this line cutting right across them, this is a transversal. Except that I spelled transversal wrong. Transversal. There should be another S in there. Transversal. Transverse. It goes across. Verse means to go. So transversal means it goes across. It cuts across these two parallel lines. And the interesting thing that happens here is that there are four types of angle relationships that come out of this scenario. When you have parallel lines and then you cut across them, there are four types of angle relationships that come out of it. Okay, and so the first type of angle relationship is a corresponding angle. Let me zoom in a little bit here and see if this will help us. Okay. The first type of angle relationship is corresponding, and these are congruent to each other. And so on my diagram here, I have my two parallel lines in the transversal. I'm using the same diagram for all of these examples to make it easier to understand. And so the corresponding angles, there are many types, or many sets in this scenario, but here's a corresponding angle. So this angle right here, right, is corresponding to this angle because, and I've called these angle 1 and angle 2. They're corresponding because if you look at each of these little intersections as its own little thing, okay? If I just look at that intersection and then this intersection of these two lines, do you notice, let me cover this one up. Okay, so angle 2 is kind of in the bottom right of the intersection. If you imagine two little roads intersecting, angle 2 is in the bottom right intersection. And if I look at this one, angle 1 is in the bottom right intersection. So they're in the same position, relatively speaking, on each of the intersections. And so because they're in the same position, we say they're corresponding because they're in the position that corresponds with itself in the other intersection. The next kind is an alternate interior. Alternate interior, and these are also congruent. And in this scenario here, I have indicated angle 1 and angle 2 are alternate interior. They're alternate because they are on opposite sides of the transversal. So if you notice here, if I draw in this transversal, they are on opposite sides of the transversal, right? Angle 1 is on this side and angle 2 is over here. So they're on opposite sides of the transversal. That's what makes them alternate. Okay, that's what that word means. Now the interior part means that they're on the inside of the parallel lines. So if I draw in the parallel lines in green, notice that the two angles I'm talking about are on the inside. They're both on the inside of the two, I just drew those little arrows going in. They're on the inside of the two parallel lines. So because they're on the inside of the parallel lines, they're called interior, and because they're on opposite sides of the transversal, they're called alternate. So together it's alternate interior angles, and they are always congruent. Similarly to that, we also have alternate exterior, which also happen to be congruent. And the same kind of a thing applies to this. They're alternate because they're on opposite sides of the transversal. Notice they're still on opposite sides, but the difference is, right, because angle 2 is on this side, angle 1 is on this side of the transversal. But notice that this time, in respect to the parallel lines, they're on the outside, right? So we've got this parallel line going like this, and this parallel line going like this, and the angles I'm talking about are, oh, that's not really on there, excuse me. They're on the outside, so they're on the top and on the bottom of the parallel lines. So because they're outside of the sandwiched part in between the parallel lines, they're outside of the sandwich, they're exterior. And because they're on opposite sides of the transversal, they're alternate. So together it's alternate exterior, and those are always congruent. The last kind is consecutive interior. So again, these, as you can tell, these are going to be on the inside of the parallel sandwich. But consecutive is a little bit different. Because they're consecutive, they're going to be supplementary. They're not going to be congruent this time. So again, here, they're on the inside of the parallel lines. As you can see, here's a parallel line, and here's a parallel line. It's creating that kind of sandwich thing. And so they are indeed on the inside, but they're consecutive. They're not alternate interior. They're not alternate exterior. They're actually alternate. They're not alternate. They're not alternate because they're on the same side of the transversal. So notice here that I have, they're on the same side of the transversal. They're both on the right-hand side of that transversal. Okay, they're both over here. But they're not corresponding, because if it was corresponding, angle 2 would have to be up here, right? That would be corresponding to angle 1, or angle 1 would have to be down here to be corresponding to angle 2. So they're not corresponding, they're not alternate, they're kind of on the inside. If you were to take something and kind of go around the interior here and kind of go like this and go around, then as you're going around that thing, you kind of hit one and then you turn up and you hit another one and keep on going. So it's kind of like if you're coming around the inside here, you hit one and then hit another one, and that's why they're called consecutive, because it's just boom, boom. You hit one, hit another one, and keep going on the inside. So if you think about this little loop, I think of a little U right here, and because I hit one right after the other, they're consecutive. Of course, consecutive means next up to each other or touching. And so since they're you get to them and you touch one and then immediately touch the other one, they're called consecutive. So let's look at some examples here. In this case, these are corresponding. X and Y are corresponding because they're in the same position on both intersections, and so they're corresponding. These are alternate exterior because they're outside of the parallel lines, and they're on alternate sides of the transversal, so they're alternate exterior. Here's another corresponding because they're in the same position on both. Consecutive interior because they're interior, but notice that they're not corresponding and they're not alternate, so they're on the same side, and it's kind of this whole thing where you're going around like this, and you hit one, you hit boom, boom, back out. So it's consecutive interior. Alternate interior because they're alternate and they're on the inside. Alternate exterior here because they're alternate on the outside. Here's a little bit more complicated diagram with 3 parallel lines. Just keep in mind that. These are alternate interior because if you notice, this line right here I've just put in as to throw you off. So if you ignore that line, these are in fact alternate interior angles. And so if I made that one angle Z, that would also be alternate interior. Okay. Of course, Z would be alternate interior to X, but Z and Y would be corresponding. It doesn't matter because they're all congruent. Everything except the consecutive ones are congruent. These are alternate exterior because this one and this one are alternate exterior, and ignore this line right here. I just put that in to throw you off. So these are alternate, and they're on the outside of these 2 lines. Okay. So let's do something a little bit more involved with all of this. Let's do something that takes a little bit more thinking. Find the measure of each angle indicated. Well, this is 110. This is the question mark, but those are alternate exterior, so it's also going to be 110. These are alternate interior, so the question mark is congruent to the 84. These are consecutive interior, right? And so it's going to be supplementary. If that's 100, then this has to be 80. These are alternate interior, so they're congruent, so the question mark is 111. These are alternate exterior, so they're congruent, so the question mark is 47. Now let's take this one more step further and say, okay, well, if I have something like this, let's solve for x. Well, if you notice here, this is alternate exterior to that, right? And this is 90, so 90 has to be congruent to this expression. So we would just set it up as 21x plus 6 equals 90, because those have to be congruent. And so then we subtract the 6, and then we get x equals 4. Okay, by dividing everything by 21 here, x equals 4. Here, these are corresponding, so they're congruent. So the setup is 11x minus 2 equals 75. Subtracting 2, or excuse me, adding 2, we get 77, and dividing by 11 we get x equals 7. Okay, these two angles right here are alternate interior, so they have to be congruent. And so if we set this up, 8x minus 4 equals 60, so 8x equals 64, and so x equals 8, which was the answer key right there. Okay. All right, so we'll do this one last. These are corresponding, so they have to be the same. So 23x minus 5 equals 21x plus 5. Getting rid of the 5s, or excuse me, not getting rid of the 5s. Oh my gosh. So we'll add 5 and we'll add 5. So 23x equals 21. Oops, I'm off the screen here. 21x plus 10. Subtracting 21x. And we get 2x equals 10, and so x equals 5, and which is exactly what they had up here. So find the measure of the angle indicated in bold. So this is the measure of the angle. This is the angle indicated in bold. See how it's bolder than this other one? But these have to be supplementary. So x plus 96 plus x plus 96 is 180. And so this is 2x plus, what is that? That's 192 equals 180. So then 2x equals, subtracting 192 equals a negative 12, and so x equals negative 6. So if we plug this in, if we plug in the x equals negative 6 here, then this angle right here becomes negative 6 plus 96, which equals 90. Okay? And I'll do one more of these. These are corresponding, so they're going to be congruent here. And so 6x equals 5x plus 10. The 6x is the one indicated in bold. If we subtract 5x, we'll just get x equals 10. And so then plugging this in right there, 6x equals 60, which is what that was the answer right there. I've just covered it up with that 2.